This is a question that comes up a lot in VCE math methods, whether it is in exam 1 or exam 2. And today I'm going to show you two ways to approach this problem. The first method of solving this problem is by using transformation equation, which I believe is the foolproof method, but only if you execute it correctly. The second method is by deducing the transformations based on comparison, which means you basically deduce the transformation by comparing the original function to the image function. So let's start off with our first method. So the first thing I want you to do with this method is for both the original function and the image function, I want you to isolate y and x. So let us start. For the original function, let us isolate y and x. So we divide both sides by -3. So that'll give us -1/3y equals e 2x plus 5. And for the second, for the image function, divide both sides by 6, gives us 1/6y e x on 3 minus 4. And I want you to put it in this form. I want you to put the part with x and y in a transformation equation. Let me show you how. So for the for the original function, we'll have this form, where this is our y part and this is our x part. And then, since we're going from this to this, we will write it in this form. Where this is our x part from our image function, and this is our y part. And since this is the image, we want to denote it as x prime and y prime. The next thing I want you to do is equate. So we have 2x plus 5, which is our original function, equals 2x on 3 minus 4. Since we're going from 2x plus 5 to x prime on 3 minus 4, and then to find the transformations that map x to x prime, we want to equate and then transpose to make x prime the subject. So let us do that. So 2x plus 5, you move -4 to the other side, so you get 2x. You add 4 to both sides, that'll give you 2x plus 9. And then you multiply both sides by 3, that'll give us 6x plus 27. So now what about our y side? Let us equate again. So -1/3y equals 1/6y prime, and you make y prime the subject. So you multiply both sides by 6. That'll give us -2y, because -1/3 times 6 equals -2. Yep. So now we can start listing out our transformation. The first thing I want you to identify is the dilations, which is very important because order matters. Identify dilation, then and reflection, because it's fine if you mix up the order for your dilation and reflection, but it is really important that you do not mix up the order between dilation and reflection and translation. So make sure you identify your dilation and reflection first before identifying your translation. So, nuance, identify dilation and reflection, and then translation. So, we start off by looking at this. That is a dilation by factor 6 from the y-axis. Why? Because we're multiplying our x-coordinates by 6. So then we're stretching out our graph horizontally, dilating away or pulling away from the y-axis. And then for our y-coordinates, that is a dilation by factor 2 from the x-axis. Why? Because we're multiplying our y-coordinates by 2. That means we're stretching our graph and pulling it away from the x-axis. That is why it is called a dilation by a factor of 2 from the x-axis. If you want more information, please watch my video on dilation, transformation, and reflection. Dilation, reflection, and translation. So we've got those two, and then the next is reflection. We're reflecting in the x-axis because we're multiplying our y-coordinates by -1. Now that we've got our dilation and reflection, it's time to identify our translation, which is very simple. We're translating by 27 units right, or in the positive direction of our x-axis. And that's basically it.